In this video, you will learn how to solve equations by multiplying or dividing. So to begin, let's do an illustration. So let's suppose that a pound of chicken costs the same as a pound of turkey. Okay, let's say that price maybe is $3. So $3 per pound. Okay, so both are $3 per pound. So if you were to purchase the same amount of chicken as you do turkey, you would expect to pay the same for both, right? So if you buy 2 pounds of chicken, that means you pay $3 per pound times 2 pounds, so 3 times 2 would be $6 total. And then same thing for turkey. If you buy 2 pounds of turkey, the same amount, you would also buy 6 pounds of turkey, or $6 of turkey. And same thing for 1/2 pound of chicken and 1/2 pound of turkey. You're going to pay the same amount for both. And that is the idea of what we call the multiplication property, because we started with $3 for both chicken and turkey, and we multiplied both of those by 2 because we had 2 pounds. So $3 per pound times 2 pounds, do that on both sides, we have the same amount that we paid for both the turkey and the chicken, which we paid $6 total. So that idea where I can multiply both sides by the same number, that is called the multiplication property of equality. And we need to use this to solve different equations involving multiplication and or division. So in math notation, we would say that if a, b, and c are any real numbers, and a is equal to b, then I can multiply both numbers, both values, by the same thing to have a true statement. So if I multiply both sides by c, then c times a would equal c times b. Or we can switch the order of multiplication, so instead of c times a, we can have a times c. Instead of c times b, we can have b times c. So bottom line, we can multiply both sides of an equation by the same number. So for example, let's say we had the equation x divided by 4 equals 6. Now, as we stated in the previous lesson, in order to solve equations, we need to do inverse operations to move things away from the variable so that we can solve the equation. So here, for example, we want to get x by itself so that we have something like x equals some number. So we need to get rid of the 4 with the x on this left side. So remember, fractions means division. So what this says is that some number x divided by 4 equals 6. So to solve this, we need to do the opposite of dividing by 4, which would be multiply by 4. So we multiply both sides by 4. And when I do that, on the right side I have 24. 6 times 4 is 24. And on the left side, the 4's would cancel out. Okay, so we'd have x on the left side equals 24 on the right side. And sometimes people struggle seeing why the 4's would cancel. Two ways to think of it. One, as we stated, is that multiplying and dividing are inverse operations, so they cancel each other out. Another way is if we think of this as x over 4 times 4, or 4 over 1. Our rules of fractions says that I can multiply the numerators to get 4x, 4 times x, and the denominators, 4 times 1, to get 4. And then 4 divided by 4 would cancel, which gives me x. So either way, we get x on the left side and then 24 on the right side. And we can double check our answer by plugging 24 back in for x. So 24 divided by 4 equals 6 is a true statement. So therefore 24 is the solution. Here are some more examples. Here we have m divided by 4 equals -6. Well, as we stated, to get rid of the division, we do the inverse operation, which is multiplication. So instead of dividing by 4, I'm going to multiply both sides by 4. When I do that, on the left side, the division of the 4 and the multiplication of the 4 will cancel out, leaving me with just an m on the left side. On the right side, we have 4 times negative 6, which would be negative 24. So my solution is m equals negative 24. Example 2. We have h divided by negative 2 equals 5. So to get rid of the division of the negative 2, I need to do the inverse operation, which is multiply by negative 2. So I multiply the left side by this negative 2 and the right side by negative 2. The division and multiplication of the negative 2 will undo each other and they'll cancel out. So on the left side, I have h left over. On the right side, I have negative 2 times 5, which is negative 10. So my solution is h equals negative 10. Now, this multiplication property also works the same with division. So just like we can multiply both sides of an equation by some number, we can also divide both sides of an equation by some number. So in math notation, how I would state this is that if a, b, and c are any real numbers, and a is equal to b, then a divided by c would equal b divided by c. So bottom line, in English, this says that I can divide both sides of an equation by the same number. In this math notation, we're dividing both sides by c. So for an example, we have 4x equals 24. Now remember, 4 next to the x means that we are multiplying. So what this says is 4 times x equals 24. And this one is simple enough to do in your head. We know that 4 times 6 is 24, so x would be 6. But how would you solve this by going through the steps? Well, this says 4 times x, so we're multiplying by 4, right? X times 4. So to get rid of the multiplication, I do the opposite. So instead of multiplying by 4, I will divide both sides by 4. So here we see that we divide the left side by 4 and the right side by 4. The multiplication and the division of 4 will cancel each other out. 4 divided by 4 gives me 1. So I have 1x. So the left side I have 1x, or just x. And then on the right side, 24 divided by 4 equals 6. So my solution is x equals 6. And we can double check by plugging the number back in for x. 4 times 6 equals 24. That is a true statement, so therefore we have the correct solution. Here is another example. 6x equals 216. So this means 6 times x. So to get rid of the 6, because it's being multiplied, I do the opposite, which is divide. So I divide both sides by 6. On the left side, the 6's will cancel. So I have just x on the left side. On the right side, I have 216 divided by 6, which would be 36. So my solution is 36. And we can double check by plugging it back in for x, and we'd have 6 times 36 equals 216, which is a true statement. Therefore, we have the correct solution. Here is another example. Here we have negative 5x equals negative 30. Be careful with this one, because negative 5 is just one number. We're not subtracting 5 from x. It's multiplying negative 5 by x. So we are multiplying here. And so to get rid of this negative 5 that we have multiplied, we do the inverse operation, which is divide. So I divide the left side and the right side by negative 5. So negative 5 divided by negative 5, that would undo itself. So those would cancel out, because negative 5 divided by negative 5 is 1. So we have 1x, or just x, on the left side. on the right side, negative 30 divided by negative 5. Negative divided by negative gives me a positive, so this would be a positive 6. Example 5. We have negative y equals 40. Now remember, if there's nothing in the front, there's no number in the front, it's an assumed 1. We have 1y here. So to get rid of the negative 1, because we want this to be y equals, to get rid of that, this is negative 1 times y, so we can do the opposite, which would be divide. So we divide both sides by negative 1. When I do that, the negative 1's cancel, giving me a positive 1. So we have 1y, or just y, on the left side. And on the right side, we have 40 divided by negative 1, which is negative 40. So my solution is y equals negative 40. And if you get good at this, you don't need to go through all of these steps to get this answer. You can if you want. But if you think back here at negative y equals 40, if negative y equals positive 40, then positive y would equal a negative 40. We just change the signs to get our solution. Now to finish off, we need to know how to translate different English expressions into math notation, and we will use that to then solve an equation. So here, the English phrase would be 8 times a number. So in math notation, whenever you see the phrase a number, we can replace that with a variable because we don't know what it is, so just put a letter there in place of that. So many times we use the letter n for number. So 8 times n we would write as 8n. That is the same thing as 8 times n. So next we have twice a number. So twice means 2 times something. So 2 times a number, so 2 times n, which can be written as 2n. Next we have 1/8 of a number. So 1/8 is a fraction. You could write that as 1 over 8. Of means multiply. A number, you can let a variable represent a number, and we'll use the letter n. So you can write that as 1/8 times n, or 1/8 n. Or, as we see here on the left, if you take 1/8 of something, that means you're dividing by 8. Right? If you have the number 16 and you find 1/8 of 16, we take 16 divided by 8. So we can express this as n over 8 or 1/8 times n. Next we have quotient of a number and 5. The word quotient means divide. So we are dividing a number by 5. So n divided by 5. In math notation, I can write that, like this, n divided by 5, or as a fraction, n over 5. Or as we did over here, we can think of that as 1/5 of n. So 1/5 times n. Either way, that is the same expression. Next we have quotient of 5 and a number. So it's pretty much the same as the last one, just make sure you're dividing correctly. So the last one was n divided by 5. Here we have 5 divided by n. So now, using everything that we've learned so far in this lesson, we're going to now set up an equation, and then we are going to solve the equation that we set up. So it's going to be a word problem. So you're given that Jimmy donates $9,000, which is 1/5 of his income. And then the question is, what was Jimmy's income? So when you set up an equation, you want to ask, what is your unknown variable or unknown value? So the question is asking, what was Jimmy's income? So that is what is unknown. So the unknown value is Jimmy's income. And we'll let that be our variable. So we'll call that x. So Jimmy's income is x. And the question is, how can we use the information given along with the variable to write an equation. So we know that Jimmy donated $9,000, which is 1/5 of his income. So 1/5 of his income, so 1/5 times his income, 1/5 of it is equal to $9,000. Okay, so his income was our variable, so that was x. So we have 1/5 times his income, or times x, equaling $9,000. So this would be our equation. And as we stated previously, 1/5 of something would be the same thing as taking that number and then dividing by 5. Right? If my number was 20 and I said find 1/5 of 20, I take 20 divided by 5. So that's what we're doing. We're taking his income, dividing it by 5. That equals $9,000. So that is my equation. So from here, we need to solve this equation. So to solve, we do the opposite of dividing by 5. So the opposite of dividing by 5 would be multiplying by 5. So I multiply both sides by 5. The 5s would cancel on the left side, which leaves me with x. On the right side, I have 9,000 times 5, which is 45,000. So my answer is $45,000. That is Jimmy's income.